Hello friends, good afternoon everyone. I am fine. How are you? I hope you will be fine. Welcome back in my channel, Dr. Satendra. Dear friends, if you want this type of videos related to mathematics for higher level, then you need to subscribe, share and like my videos and my channel. Today we will discuss complex variable differentiation short type question. Now question number first. If fz equal u plus iv is analytic, then show that the family of curves uxy equal to c1 and vxy equal c2 are mutually orthogonal. This question has been come MTU 2012. Solution: uxy equal to c1 and vxy equal c2 are two family of curves. Differentiate, then we get del u upon del x dx plus del u del y dy equal to 0. Similarly, del v upon del x dx del v upon del y dy equal to 0. Now we can calculate dy dx cm1 equal minus del u upon del x upon del u upon del y. Similarly, m2 equal dy upon dx equal minus del v upon del x upon del v upon del y. Now we can create both curves slope. We know that fz is analytic, then this function hold CR equations. What is CR equation? So CR equations are del u upon del x is equal to del v upon del y and del u upon del y equal minus del v upon del x. Now multiplied m1 and m2, we get minus del u upon del x upon del u upon del y into, now putting the value of del v upon del x, del v upon del y, minus plus. There are two conditions: if you change u in v or v in u. Now u is same, del u upon del x upon del u upon del y as it, minus plus. Now putting the value del v upon del x, this is equal to minus del u upon del y upon del v upon del y is equal to del u upon del x. This cancel by this is cancel by this is equal to minus 1. This is a condition of orthogonality. Now given family of curves, family of curves are mutually orthogonal. Okay, student. Now next question number 2. Using the Cauchy-Riemann equation, Cauchy-Riemann equations so that fz equal z modulus square is not analytic at any point has been come MTU 2013. Now repeat the question. By using Cauchy-Riemann equations so that fz equal to z modulus square is a not analytic. Now fz z modulus square, now u plus iv equal to x plus iy modulus square, u plus iv, this is equal to x square plus y square. Now comparing u equal x square plus y square and v equal 0. Now del u upon del x equal to 2x, del u upon del y equal to 2y, and del v upon del x is equal to 0, comma del v upon del y will be 0. We have del u upon del x is not equal to del v upon del y, and del u upon del y is not equal to minus del v upon del x. Therefore, CR equation are not satisfied. That is, we can say fz is not analytic anywhere. Fz is not analytic at any point. Since fz does not hold Cauchy-Riemann equation. Now next question number 3. Write down the Cauchy-Riemann equation. Cauchy-Riemann conditions or equations in polar coordinate system has been come AKTU 2016. Answer: del u upon del r equal 1 upon r del v upon del theta, and del u upon del theta equal minus r del v upon del r. There are Cauchy-Riemann equation in polar form. Okay, student. Now next question number 4. Define analytic function. Define analytic function and state the necessary and sufficient condition for function to be analytic. condition for function to be analytic. This question has been come MTU 2012. Okay, student. Now first we provide a definition of analytic function. Now analytic function is a heading. Now definition of analytic function. A function fz is said to be analytic. A function fz is said to be analytic at a point z0 if it is one valued and differentiable not only at z0 but at every point of some neighborhood of z0. Now repeat. A function fz is said to be analytic at a point z0 if it is one valued and differentiable not only at z0 but at every point of some neighborhood of z0. Okay. The necessary and sufficient condition. The necessary and sufficient condition for the function w equal fz equal u plus iv to be analytic in a region R. R number first. Del u upon del x, del u upon del y, del v upon del s, del v upon del y are continuous function of x and y in the region. Number second, del u upon del x equal to del v upon del y and del u upon del y equal minus del v upon del x. These equations are CR equation. Now repeat. Necessary and sufficient condition for this is the statement of function to be analytic. Then find out the necessary and sufficient condition. So answer is the necessary and sufficient condition for the function w is equal to fz equal to u plus iv to be analytic in region R are number first condition del u upon del x comma del u upon del y comma del v upon del x comma del v upon del y are continuous function of x and y in given region. Number second, del u upon del x is equal to del v upon del y and del u upon del y is equal to minus del v upon del x. These are the CR equation. Okay, student. Next question, question number 5. State Milne-Thomson method. Milne-Thomson method. तो by Milne-Thomson f z is equal to integral bracket phi 1 z comma 0 minus I psi 2 z comma 0 bracket close dz plus constant, where c is a arbitrary constant. We have value of phi 1 z0 can be written as by del u upon del x on putting x equal to z, y is equal to 0 in this. Now repeat again. In del u upon del x we put x is equal to z, y is equal to 0, then we get phi 1 z0. Similarly, if we put del u upon del y, x is equal to z, y is equal to 0, then we get value of psi 2 z0. Okay, student. Now next question, question number 6. Find the point of invariant. Find the point of invariant of the transformation w equal to z plus 3 upon z plus 2. Now answer. For point of invariance, for points of invariant, we put w equal to z in given transformation, that is z equal to z plus 3 upon z plus 2. Now by cross multiplication, z square 2z equal to 2z plus 3, that is z square is equal to 3. Now z equal plus minus under root 3. These points are invariant points. Now next question, question number 7. Prove that sin hz is analytic. This question has been come AKTU 2017. Now answer. Fz is equal to sin hz. Since we know that sin I theta is equal to sin hyperbolic theta. Now fz u plus iv, this is equal to sin iz upon I. Now minus I sin I value of zx plus iy, minus I sin ix minus y. This is equal to minus I sin ix. This is the formula of sin a minus b. that is sin ix cos y minus cos ix sin y. Okay, student. Now minus I. The value of sin ix is equal to I sin x, I sin hx, cos y as it, minus cos hx sin y. Now multiplied I sin hyperbolic x cos y plus I cos hx sin y. Now comparing, we get u equal sin hyperbolic x into cos y, and imaginary part v equal cos hyperbolic x sin y. Now we get del u upon del x cos hx cos y, comma del u upon del y equal minus sin hyperbolic x sin y, and del v upon del x is equal to sin hx sin y, comma del v upon del y is equal to cos hx cos y. Now we get del u upon del x is equal to del v upon del y. The value of del u upon del x cos hx cos y, del v upon del y cos hx cos y. Okay. Now value of del u upon del y is equal to minus sin hx sin y. Sin hx sin y value of del v upon del x. Now minus del v upon del x. These are the CR equations. CR equation. Now we know that every function which holds CR equation, function will be an analytic. Hence sin hz is analytic. Okay. Now next question. Question number 8. Find the constant constants a, b, c such that the function fz equal minus x square plus xy plus y square plus I into ax square plus bxy plus cy square is analytic. This question has been come MTU 2013. Okay, student. Now answer. Fz, that is u plus iv, this is equal to minus x square plus xy plus y square plus I into ax square plus bxy plus cy square. Now comparing real and imaginary. Now real part u equal minus x square plus xy plus y square, and imaginary part v equal ax square plus bxy plus cy square. Now del u upon del x equal minus 2x plus y. Similarly del u upon del y can be written as x plus 2y, and del v upon del x is equal to 2ax plus plus by. Now del v upon del y is equal to bx plus 2cy. Okay, since function is analytic, now CR equation will be hold. So CR equations are del u upon del x is equal to del v upon del y and del u upon del y equal minus del v upon del x. Now put del u upon del x. 2x plus y equal del v upon del y. Bx plus 2cy. Now comparing the value of coefficient of x, this is equal to b. Now here minus 2. Now comparing coefficient of y, this is equal to 2c. Here 1. That is c is equal to 1 upon 2. There are, we calculate two value b and c. Now here del u upon del y, x plus 2y. This is equal to minus del v upon del x, 2ax plus by. Now comparing coefficient of x both side, this is equal to 1, this is equal to minus k2a. That is a is equal to minus 1 upon 2. This is the repeat of value of b equal to minus k2. Not necessary. Now value a is equal to minus half, b is equal to minus 2 and c is equal to half. Okay student. Now next question, question number 9. Find the value of a and b. Find the value of a and b for which the function fz equal cos x into cos hy plus a sin hy plus I sin x into cos hy plus b sin hy is analytic. Is it analytic? Now answer. fz is u plus iv. Now value of fz is given cos x into cos hy plus a sin hy plus I sin x into cos hy plus sin hy. Now comparing real and imaginary. Now real part u equal cos x into cos hy plus a sin hy. Now imaginary part v is equal to sin x into cos hy plus b sin hy. Now we calculate del u upon del x, that is we get partial differential with respect to x of u minus sin x cos hy plus a sin hy as well as now del u upon del y cos x as it, well, differentiation of cos hy sin hy. Now differentiation of sin hy cos hy. Similarly we can calculate partial differential with respect to x of v, that is del v upon del x cos x cos hy plus b sin hy as it. Now partial differential with respect to y of v, sin x as it sin hy plus b cos hy. Since function is analytic, now CR equation will be hold. CR equations are del u upon del x is equal to del v upon del y, and del u upon del y is equal to minus del v upon del x. Now putting the value of del u upon del x, minus sin x cos hy plus a sin hy is equal to del v upon del y sin x sin hy b cos hy. Now del u upon del y cos x sin hy a cos hy equal minus del v upon del x cos x into cos hy plus b sin hy. Now comparing sin x cos hy, sin x cos hy. Now the coefficient of sin x cos hy, here minus 1 and here b. Now b is equal to minus 1. Now taking coefficient of sin x sin hy is equal to minus a. The coefficient of sin x sin hy here plus 1, that is b is equal to minus 1 and a is equal to minus 1. Similarly, we calculate the coefficient of cos x sin hy, cos x sin hy. The coefficient here 1 or coefficient here minus b, that is b is equal to minus 1. Okay, both value are same, that is my assumption is correct. Similarly, the coefficient of cos x cos hy, here a or here minus 1, the value of a will be same. Okay student, here value of a minus 1 and value of b minus 1. Okay student.